Okay, so what if the biggest mysteries in the universe, dark matter, dark energy, what if they could be solved not with some crazy new discovery, but with a single fundamental law that's been hiding in plain sight? Today on The Explainer, we are digging into a theory so audacious, its creators are actually calling it the last law.
So, let's just start with a really provocative idea. What if that huge chunk of our cosmos, the part we've labeled dark and mysterious, isn't a missing piece at all? What if it's just a symptom of a basic rule of the universe that we haven't quite grasped until now?
For decades, the standard model of cosmology has been our roadmap. And look, it's been incredibly successful. But it leaves us with this pretty wild picture. A universe where everything we can see, everything we can touch, all the stars, planets, and galaxies, that's only about 5% of everything. The other 95%? We literally have no idea. It's a complete mystery.
Now, the authors of this new theory, they do not pull any punches. They flat out argue that things like dark matter and dark energy aren't actual discoveries. To them, they're just placeholders, mathematical fudge factors we've plugged in to make the data fit the theories we already have.
So, if that's the problem, what's their solution? Well, it's a theory called the Unified Chronofractal Field, or UCF for short, and this is where things get really radical. It doesn't start by analyzing data from telescopes. Nope. It starts with a single logical statement, an axiom, that it claims is just a non-negotiable feature of reality itself.
The UCF is making a huge claim here. This isn't just another model that we can tweak and adjust as new data comes in. The authors are presenting it as a fundamental law, something designed to completely replace the old way of thinking, a total demolition. And it all comes down to this one simple-looking equation. The theory basically says that for the universe to be consistent with itself at every single scale, from the tiniest quantum level to the largest cosmic structures, it has to obey this one simple rule. This isn't something they found in observations. They're saying it's a ground floor logical necessity for the universe to even exist.
And here's where it gets really fascinating. That little equation only has one physically meaningful solution, a number the theory calls nu. And it just so happens to be the golden ratio conjugate, a very close cousin of that famous number you see everywhere in nature and art. The theory is basically saying, hey, that's no coincidence.
So according to the theory, this number isn't just a mathematical quirk, it's the fundamental operating system for all of reality. It suggests that time itself isn't this smooth, straight line, but that it actually has a repeating, fractal structure that's defined by this one number. It's like the core DNA from which the entire cosmos is built.
Okay, so how on earth does this one number get rid of dark matter? How does it explain something so concrete like why galaxies are spinning way faster than our current theories say they should be?
Well, instead of inventing some invisible matter, the UCF proposes this new principle called historicity. The idea is that space-time has a memory. Think of it like a memory foam mattress. It holds the impression of where someone used to be. The theory says the gravitational field we feel today is still being influenced by where mass used to be millions of years ago, and that leftover pull is what we've been mistakenly calling dark matter.
And that brings us to the theory's main event, its explanation for dark energy. Now, it doesn't try to explain it with some new force or particle. Instead, it claims the properties of dark energy can be derived from pure logic, that it's just a geometric inevitability of a universe built on this fractal foundation.
All right, I know this slide looks a little technical, but the idea behind it is actually pretty simple. Here's the logic. Step 1 is just standard physics. It's the normal rule for how energy spreads out as the universe expands. Step 2 is the UCF's rule, which is just a little different because of its weird fractal time. In step 3, they just say, look, these two rules have to be describing the same universe, so they must be equal. And when you solve that, you get step 4, a precise, unavoidable formula for W, the number that basically defines what dark energy is.
So here is the crucial point. When you plug in that axiomatic value of nu, you get a hard-fixed, totally parameter-free prediction for the nature of dark energy today. This isn't a range, it's not a fit to data, it's a single falsifiable number that the theory has to live or die by. And, a theory this bold, it has to be testable. The UCF doesn't just allow for this, it absolutely demands it. The authors have laid out very specific pass-fail tests for their own theory, a challenge they're calling the gauntlet. And here we are, the confrontation with reality.
So that first line, the theory's prediction for dark energy's current state, that negative 0.794 number, it lines up shockingly well with the latest preliminary data. But the second line, that's the real battleground. The UCF predicts dark energy is thawing, meaning it's getting weaker over time. Most other models predict the opposite, that it's freezing. These are totally mutually exclusive. One of them has to be wrong.
The UCF also takes a direct shot at its main rival in the no dark matter camp, a theory called MOND. And the claim here is pretty simple. While MOND really only tries to explain why galaxies rotate the way they do, the UCF aims to explain that plus gravitational lensing and dark energy, all from that single starting axiom.
So this all leads to the final, really high-stakes question. What happens next? A theory can't just live on paper forever, right? It has to face the ultimate judgment of real-world observation.
So the UCF has a very clear timeline for its judgment day. The biggest test is coming in October 2026. Data from the Euclid Space Telescope is expected to finally settle the debate. Is dark energy thawing, just like the UCF predicts, or not? It's a single measurement that could either validate the whole theory or send it completely crashing down.
The authors are stating their case with this really quiet confidence. They've built their chain of logic, they've published the proofs, and now they're just waiting for our observations to catch up to the math.
And really, that's the ultimate takeaway here. We have a theory that is precise, it's falsifiable, and it is unbelievably ambitious. It is either going to be profoundly right or just spectacularly wrong, with a definitive verdict from the universe itself potentially right around the corner. I guess the only thing left for us to do is watch.